Okay, that's great, Sonu. Thank you. So, guys, in the previous class, we discussed with the nodal analysis, and I told you how to apply the direct nodal method on supernode. Okay, and now it's time for more practice. We will try to understand some new concept in the nodal. So there is one more class on nodal, and today's class is also devoted on the nodal analysis, so that you can get the better idea of nodal, and you can even solve the difficult questions from nodal. Okay, so let's complete the introduction part first, so that everybody can join in the meantime. And don't forget to like this session, guys. Let's make 50 likes in this session. And okay, so don't forget to like, please like this session, and in the meantime we can complete the introduction part, and then after we'll start the session. Okay, so this is my introduction. My name is Asu Jangda, and I'll teach you almost every subject of network of electrical engineering, and right now I'm teaching network theory. Okay, the student who want to join BYJU'S exam prep at lower cost, let's say if your financial condition is not good, then you can attempt this test. In this test you can get 90% scholarship. Okay, and this test will be on 19th of March at 12 p.m. So you can register for this test, and the link for the registration is given in the description. Okay, so you can go there and you can attempt this test to avail this scholarship. Okay, there is one more series which is going to start from 19th of March, and this series will be Coffee with Concepts. And this series, in this series we will try to take some new concepts in a compact form, and I hope you will love it. Okay, and this will be twice a week. For electrical electronics it will be on Wednesday and Sunday. Okay, so you can join this series also. You can take advantage of this series also. Those students who have appeared in ESE prelims and those students who have cleared for mains, please tell us, and at least message me, so that I can advise you for the how to prepare for the mains, and how to write the answer. So everything, because we are going to launch a new batch for main student, and this batch will be in private domain. It will be free of cost. So we will advise you, and for that you have to contact me. So you can send me a message. Okay, and then after I will tell you the process. Okay. For NIELIT 2023, there is one crash course which will be starting for ECE and Computer Science Engineering. It will be from 18th of March, so you can also take advantage from this session. Okay, in this session the technical part will be on Monday, Wednesday and Friday. Okay, so let's proceed, guys. Now it's time for the Guru Dakshina. So you have to give the Guru Dakshina, and that is, don't forget to subscribe this channel if you have not subscribed it, and please like this session and press the bell icon, so that whenever my session is live, you'll get the notification. Okay, so tell me, guys, are you ready? Can I start the session? Tell me, can I start the session? I think everyone is ready. So let's start the session, guys. In the previous class I told you about supernode, if you remember. In this class also, let's discuss about supernode. Let's try to solve one question. Okay, now you can see this question. In this question, we need to calculate this I naught current. We need to calculate this I naught current. Let me select one pen. Okay, yes. So we need to calculate this I naught current. Okay, now how to calculate this I naught current? We know that there are many junctions, like this is one junction, 2, 3 and 4. So actually there are 4 junctions. Out of these 4 junctions, let's say this is a reference point. I take one as reference. If this is the reference point, let's call it VA. Let's call this voltage as VA. And we know that between this junction and this junction, there is a direct voltage source. So it will make a supernode. It will make a supernode. Okay, it will make a supernode. Similarly, this junction and this junction will again make a supernode. Okay, because the voltage source is directly connected between them. So again it will make a supernode. You can see that. So actually this node and this node, they will make a supernode. Okay, so now we can apply the supernode concept if you are assuming this as a reference point. Okay, So reference I have taken as 0 volt. So with respect to 0, it is VA. If it is VA, then it will be VA plus 10. And it will be VA minus 5I1. Minus 5I1. I hope it is clear. Okay. So VA minus 5I1. Now what I need to do is, now I need to apply the direct nodal method to calculate this VA. Okay, now tell me guys, what is the coefficient of VA? Let's write the coefficient of VA. So with the help of this question, I am trying to say that even if there is a dependent source which is directly connected between two junctions, it will make a super node. Okay, so with the dependent source or independent source, it doesn't matter. Okay, you can apply the super node concept. Okay, because many students are confused with the dependent source. Dependent source will also act like independent source, so don't worry. Okay, take it as an independent source. Now let's try to write the nodal equation. We need to find this VA first. Once we get this VA, we can easily find this I naught. Okay, so we need to write the equation for VA. Now tell me, what is the coefficient of VA? The coefficient of VA will be, tell me the coefficient of VA, it will be 1 by 10 plus 1 by 10. Now this 1 by 10 will not appear in the equation because there is a current source here. VA is appearing at this junction also, at this junction also, at this junction also. So not only this resistance will participate, this will also participate, this will also participate. Actually this will not participate because of this current source. Okay, so now let's write the coefficient of VA. So it will be 1 by 10 plus 1 by 10. But we will not write this 1 by 10 because of the current source. So let's come here. It will be 1 by 10 plus this 1 by 10. Okay. So this is the coefficient of VA. Let me repeat this again. 1 by 10 plus 1 by 10. This 1 by 10 will not appear in the coefficient of VA because of this current source. Plus 1 by 10 plus 1 by 10. Okay. Is equal to entering current. What is the entering current now? So the entering current in this branch is, because there is a voltage, so there is a voltage 10 volt. At this point we have 0 volt. At this point you have 10 volt. So 10 volt will try to give away the current. Okay. So it is because of this 10, current is leaving. Okay. So the leaving current will be 10 upon 10 minus 1. Okay. So it will be minus 1. Why it's not plus 1? Because it is not entering. It is actually leaving. That's why I have taken minus 1 here. Okay. Now let's come to this branch. In this branch, because of this 40, it will try to enter the current, and this 10. At this point we have this 10 volt. This 10 will try to leave. So the net effect will be 10 try to leave, 40 try to enter. So the resultant will be 30. Okay. Because of 30 volt, current will try to enter. And how much current it will enter? 30 upon 10. That is 3. Okay. So plus 3. I hope it is clear. Okay. Plus 3. Now, from this point you can come directly to this point, and you can see that the 5 ampere will try to enter. Okay. So plus 5. Now come to this point. At this point you can directly see that this 20 will try to enter the current, and this 5I1, since it is negative, it will also try to enter the current. It is not positive, it is negative. Okay. Because of this minus 5I1, current will also try to enter. How much current it will try to enter due to 20? Due to 20, 2 ampere will try to enter. And because of this 5I1, how much current try to enter? 5I1 upon 10. Because it is negative, that's why it will try to enter the current. I hope it is clear, guys. If it were positive, let's say, then because of this 5I1, current will try to go away. Okay. But if it is negative, negative means it will try to take the current. Okay. So the entering current will be 20 upon 10, that is 2 due to this voltage source, and 5I1 upon 10. 5I1 upon 10. This current is due to this source, and it will try to enter because it is negative. 5I1 is negative. So you can say that 5I1 upon 10 will be the entering current in this branch. Okay. I hope it is clear. Now look at this branch now. In this branch, don't look at this I1 current. This I1 current is the current due to all the sources. It's not the entering current. Okay. So entering current should be calculated using 5I1 only. Since it is negative, it will try to enter the current. How much current it will try to enter? 5I1 minus 0 divided by 10. Okay. Because there is no other source now in this case. In this branch, there is no other source. At this point, we have 0 voltage. Only 5I1 is appearing here. So what you can do is you can write the equation like this, 5I1 upon 10. Okay, so plus 5I1 upon 10, it will also try to enter the current. I mean, in this branch, entering current will be 5I1 upon 10. I hope it is clear. Okay, I hope it is clear. So this way you can write it. You can treat this as independent source. Since it is negative, it will try to enter. In this branch, because of this 20, current will try to enter 20 upon 10. 2 ampere will try to enter, but there is one more source, 5I1. And it is negative. Negative means it will try to enter. So 5I1 upon 10. Okay, it will try to enter the current. 5I1 upon 10. Now, in this branch also, there is one 5I1 upon 10. Since it is negative, so it will try to enter the current. Okay, and that will be 5I1 upon 10 again. Okay. So this will be my equation. I hope it is clear, guys. I hope it is clear. Now we can simplify this. So the coefficient of VA will be, tell me the coefficient of VA. It will be 4 by 10. And that is equal to, tell me. So it will be 8 plus 2. 8 plus 2 is 10. 10 minus 1 is 9. 9 plus, this is I1 by 2. This is I1 by 2. 9 plus I1. Okay. So you can write it like this. I hope it is clear. Now we need to find this I1. Once you get this I1 in terms of VA, you can put it here and you can solve for VA. Okay. Now how to calculate this I1? I1 is this branch current. And we can apply nodal to calculate this branch current. We know that this upper point voltage is VA minus 5I1. VA minus 5I1 minus 0 divided by this resistance 10. That is equal to this branch current I1. Okay. I hope it is clear. So we can write the nodal equation in this branch. VA minus 5I1 minus 0 divided by 10 is this current I1. Okay. So now what I can say is VA minus 5I1 is equal to 10I1. I hope it is clear. So VA came out to be 15I1 and I1 came out to be VA by 15. Is it clear, guys? So I1 came out to be VA by 15. So I can put it here. So VA, coefficient of VA is 4 by 10 is equal to 9 plus I1. I1 is VA by 15. Okay, now take this VA on this side. Take this VA on this side. So VA and the coefficient of VA will be 4 by 10 minus 1 by 15 is equal to 9. I hope it is clear, guys. From this point onward, we can calculate for VA. We can calculate for VA and we can easily solve this question. So tell me, guys, is it clear or not? Is it clear or not? Have you understood this concept? Everything is same. I have repeated the same concept. Only thing is here you have minus sign. Because of this negative voltage, current will try to enter. If it were positive, let's say we have plus 5I1. Because of this 5I1, current will try to go away. Okay. Since it is negative, so current will try to come inside. Okay. So 5I1 upon 10 in this branch, 5I1 upon 10 in this branch. Okay. I hope it is clear. Tell me, everyone. Tell me, everyone, have you understood it? So this was easy peasy again. I hope you understood this question. And now we can calculate for VA. So the LCM will be 60. Okay, LCM will be 60. 24 minus 4, that is equal to 9. Okay, so you can see that I think it will be 3. So VA came out to be 27. VA came out to be 27. Okay. So this voltage is 27. If this is 27, this will be 37 volt. Once you get this voltage now how to calculate this current I naught? Now it's very simple. Once you get this voltage, this voltage is 37. Now you can calculate this current I naught. How to calculate? You just calculate this current and this current. If you know this current and this current, you just apply KCL. This current plus this current will be this I naught current. Okay. So now it's easy peasy. You can solve it in a simple way. I hope it is clear. Okay. So guys, this was a simple question. And now there are some students who want to write the same equation using the basic method. Let's say you don't want to write the direct equation. You don't want to write the direct equation. And you want to check this equation whether I have done it correctly or whether I have done it wrong. Okay. Now, if you don't want to write this directly, then what you need to do is, again you need to write the nodal equation. But now this time you have to write the basic equation. Now how to write the basic equation? Because if you don't want to write this equation, if you don't want to go straight, then you have to write the basic equation in nodal analysis, and then you have to solve this equation. Let's say, let's write the basic equation. Let's say you don't want to write this equation, okay? Because you are not sure whether this equation is correct or not. So what you can do is you can write the direct nodal equation. I mean the basic nodal equation. How to write the basic nodal equation? It's very simple. I told you. What is this current, guys? It's a supernode. It's a big node. So at this big node, we will calculate this current, this current, this current, this current, this current, and total sum will be 0. Okay. So we can apply the KCL. Okay. Let's write the direct equation now. Let's write the basic equation. How to write the basic equation? If you don't want to write the direct nodal equation, then how to write the basic equation? We know that this is 0. Okay, we know that this is 0. This is VA. This will be VA plus 10. We know that. And this will be VA minus 5I1. Okay, and it will make a supernode with this. And this will also make a supernode with this. Okay, so it's simple. Now let's write the equation. Sir, for I naught we have to take polarity. No need for the polarity. You can apply KCL, na? You just calculate this current plus this current. This current plus this current will be my I naught current. Okay, you just apply KCL at this junction, na? This current plus this current will be equal to this entering current. Okay, this way you can calculate. But to calculate these two currents, we require VA, na? So now let's say you don't want to write, you don't want to go with the direct equation. You are more inclined towards the basic equation. Okay, because you have not understood the direct method. So what you can do is, we know that this is a supernode. If it is a supernode, then what I need to do is I need to calculate this current. This is VA plus 10. So what is this current, guys? Tell me. VA plus 10 minus 0 divided by 10. Okay, this is the current in this direction. What about this branch current? It is leaving current, remember. What about this branch current? This branch current will be VA plus 10 minus 40 minus 0 divided by this resistance. This resistance is 10. Okay, so we have calculated this current, this current. Now since it is a supernode with this, so let's come to this branch. In this branch, current is not leaving, current is entering. So let's say this is leaving current in this branch, this is also leaving current in this branch, and now we have entering current, so minus 5. Now come to this branch. In this branch, the voltage is VA minus 5I1. So the leaving current will be VA minus 5I1, VA minus this voltage, VA minus 5I1 minus 20 minus 0, minus 20 minus 0 divided by the resistance is 10. Okay, plus this current is VA minus 5I1, VA minus 5I1 minus 0 divided by this resistance, that is 10. Okay, so this will be my nodal equation. You can say that this is a big node, this is a big junction. So while writing the nodal equation, not only this current, I have to write this current also, I have to write this current also, this current also, this current also, and the total sum has to be 0. Since this current, this current, this current and this current are leaving current and this current is entering, so I have to write this as negative. So this is the basic nodal equation, and the total sum has to be 0. Because the leaving current and the entering current, the total sum has to be 0. At this big node, the total current has to be 0. Okay. Now, if you simplify this, let's simplify this. Tell me the coefficient of VA. The coefficient of VA is 1 by 10 on this side, plus 1 by 10 from this equation, plus 1 by 10 from here, plus 1 by 10 from here. I hope it is clear. Is equal to, tell me, 10 by 10, it will go minus 1. Okay, plus 1 will go on the right side and it will become minus 1. Similarly, minus 30 upon 10, it will become plus 3. Minus 5 will become plus 5. Okay, now look at this. Here you have minus 2. 20 upon 10 is minus 2. If you take it on the other side, it will become plus 2. And this minus 5I1 upon 10, it will become plus 5I1 upon 10. Okay, plus 5I1 upon 10. Similarly, from here, minus 5I1 upon 10, it will go as plus 5I1 upon 10. You will get this equation. And using the direct equation, you are getting the same answer. You are getting the same equation. That's why this is important. Okay, you can see that directly I can write this equation. There is no point of writing this basic equation. No? Why should I write this basic equation and then simplify and then get this equation? You can directly write this equation, guys. Okay. So it means the direct nodal equation is the simplified version of the basic equation itself. Okay. The direct nodal equation is the simplified. It's a direct method to write this equation. Okay. It just simplifies the equation. It just gathers this coefficient of VA and the remaining part on this other side. I hope it is clear, guys. Okay. I hope it is clear. So using this equation, we can calculate VA. Just by putting the value of I1, you can put the value of I1, calculate the I1 in this branch. I1 will be VA minus 5I1 minus 0 divided by 10 is this branch current I1. Okay. So you can put the value of I1 and you can calculate VA. So if you are writing the direct nodal equation, then your labor will be reduced. Okay. Your time, you will become fast. Okay. You can save your time. So make the habit of writing the direct equation. Okay. Don't go with the basic equation because it will take much time. And everywhere you can apply the direct method. Everywhere. Okay. There is no exception. Everywhere you can apply the direct equation for the nodal. Okay. I hope it is clear, guys. Let's take some questions. I told you one more thing. Guys, you can bypass the supernode also. But it doesn't mean that you will not learn the method of supernode. Because some students think that, okay, sir, we have learned how to bypass the supernode. Then it's no need for the understanding of supernode. No, sir. Actually, you have to understand the concept of supernode. Why? Because there are some situations in which you can bypass one supernode, but you cannot bypass the other supernode. Let's say I have one question. Let's take one question. And the question is like this. Let's say this is the question we have. Let's say I have this question, okay? Let's say this is 5 ampere, 20 volt, 10 ohm, 10 ohm, 2 ampere, 10 ohm, 20 volt, 20 ohm, 6 ohm, 40 volt, 20 ohm, 20 ohm, and this is 40 volt. Let's say we have this circuit. Now in this circuit, how many junctions are there, guys? Tell me how many junctions are there? 1, 2, 3, 4, and 5. There are 5 junctions. Okay, there are 5 junctions. Now let's say you are assuming that this point is the reference point. Let's say you are assuming that this point is reference point. So I call this as VA. So it will become VA plus 40. And it will become a supernode. It will become a supernode. Okay. Now you can say this as VB and it will become a supernode and we call it VB plus 20. So actually there are 2 supernodes. Actually there are 2 supernodes now. Okay. So now there are 2 variables. You can solve for 2 variables, no problem at all. Okay. There will be 2 equations and 2 unknown. So you can solve for V and VB. But the problem is how to write the direct equation now. How to write the direct equation now? Tell me, guys. So I have not bypassed the supernode. In the first case, I have not bypassed the supernode. I have taken the supernode. 2 supernodes are there. Actually, one supernode you can bypass. Anyone. Let's say you are assuming this point as 0. If this point is at 0, this point will be at 40 volt. Okay. This point will be at 40 volt. So this junction voltage and this junction voltage will be known to us now. Now the variable will be, let's call it VB. It will become VB plus 20 and this will be VA now. Because you have assumed 0 here. So if you are assuming 0 volt here, you can bypass this supernode. There is no need to apply nodal at this junction because the voltage of these 2 junctions are known now. Because if you are assuming that this is 0, then this will become 40. Na? If it is becoming 40, it means this voltage and this voltage is known to us. Only unknown is this junction now. Let's call it VA and this is VB. This is VB plus 20. Now you can bypass only one supernode. Okay. But it means one supernode is still there. Na? So you have to understand how to write the nodal equation for supernode. You cannot skip that, because sometimes it is possible to bypass all the supernodes. Let's say in this question, or maybe in the previous question that I have taken in the last class, in that question you can bypass the supernode, but not everywhere. Sometimes you have to apply supernode concept. Okay, so that's important, guys. You have to learn how to write the direct equation when the supernode is there. Okay, so now let's not bypass the supernode. Let's say I'm assuming that this is ground, so this is one supernode, this is one other supernode. There are two variables now. Okay, so let's write the direct equation for these variables and how to write the equations. Because let's say in the options there are two equations which are written, and you have to check which equations are correct. So you should know how to write the two variable equation using the direct method. Okay, so let's apply the direct nodal method, direct nodal equation, and write the coefficient of VA and VB. Let's write the nodal equation. So I'm writing the nodal equation at this junction. Now tell me, what is the coefficient of VA? We know that this branch is connected with these three branches, 1, 2 and 3. We will not write 1 by 6 as the coefficient. We will not write that. We will write 1 by 20 as coefficient. Yes, 1 by 20. 1 by 6 will not appear because of this current source. 1 by 20 will appear. So the coefficient of VA is 1 by 20, but not only the coefficient of VA is 1 by 20, but on this side also, you have to write this 1 by 20 and this 1 by 20 also. Okay, plus 1 by 20 and plus 1 by 20. Is it clear, guys? Tell me. This is the coefficient of VA. Have you understood it? Say yes or no. Have you understood it? So while writing the coefficient of VA, VA is not only appearing here, it is also appearing here on this junction. So not only this resistance will participate in the coefficient, this resistance will also participate, this resistance will also participate. Okay, so it's 1 by 20 plus 1 by 20 plus 1 by 20. Is it clear, guys? Now what is the coefficient of VB? Because there are two unknown, na? So in one equation there should be coefficient of not only VA, there must be coefficient of VB also, na? So what is the coefficient of VB, guys? You are writing the nodal equation at this junction and asking the coefficient of this variable. So when you are asking the coefficient of other variable and you are writing the nodal equation on this junction, remember, on VA junction you are writing the equation, but asking the coefficient of other variable VB. So the mutual branch will be used. So mutual branch is this, the connecting branch is this, VA and VB. The connecting branch is this 20 ohm only. So what I have to write is 1 by 20, and since there is a mutual branch, I have to write minus 1 by 20. Okay, just remember this point while writing the nodal equation for two unknowns, two variable. Okay, while writing the nodal equation for two variable, first write the nodal equation at this junction. Let's write the coefficient of VA. While writing the coefficient of VA, this branch is used, this branch is used, this branch is used, and this branch is used. Okay, so the coefficient of VA will be 1 by 20. This 1 by 6 will not be used, plus 1 by 20 plus 1 by 20. This will be the coefficient of VA. Now, what is the coefficient of VB? Since you are writing the nodal equation at this junction and asking the coefficient of VB, it means the mutual branch, the connecting branch, the branch which is connecting VA and VB will be used. And whenever you are using the mutual branch, you have to take minus sign. It's a process. Now your doubt will be, sir, why negative? Why you have taken negative? Because if you write the basic equation and if you simplify that, then in the mutual element you will get the negative sign. That's why I have taken negative sign. Okay, because I have derived from the basic equation. That's why I am telling you, wherever you are seeing wherever you are looking the mutual element, because you are writing the nodal equation at this junction and asking the coefficient of VB, it means the mutual branch is used, and in the mutual branch you have to take negative sign. Remember this point. Okay, so I have to write minus 1 by 20. Now equal to entering current. Tell me, guys, what is the entering current at this junction? At this junction entering current is 5 ampere from this side. Okay, there is no source in this branch. 5 ampere is entering here. Now look at this branch, because here also the coefficient of VA is there, na? So now tell me what is the entering current now at this junction? Entering current, due to this 40 it will try to enter, and due to this 40 it will try to leave. So the net current in this branch is 0. Okay, net current entering in this branch is 0. Now what about this branch? at this point the voltage is 40 volt, and this point the voltage is 0. So 40, because of this 40 current will try to leave, it will be 40 by 20 and minus, because it is trying to leave the current, so minus 2. Okay, so this is my equation number 1. Okay, I hope it is clear. So this is my equation number 1. Now what is the equation number 2? It means at this junction we need to write the nodal equation. Now at this junction we need to write the nodal equation, junction number B. So first let's write the coefficient of VA. Now tell me, what is the coefficient of VA? You are asking the coefficient of VA and you are writing the nodal equation at this junction. It means what you are trying to say is you are writing the nodal equation at this junction and asking the coefficient of VA. It means the mutual branch should be used. So it has to be 1 by 20. Since it is mutual branch, I have to take minus 1 by 20. Is it clear, guys? Minus 1 by 20 plus the coefficient of VB. Tell me the coefficient of VB, guys. Tell me the coefficient of VB. You are writing the nodal equation at this junction and asking the coefficient of VB itself. So all the branches which are connected to VB, their resistance should be used. Okay, so now tell me, at this point this branch is connected, so 1 by 10 plus this branch is connected, so 1 by 20. Now from this point you just come to this point, because here also you have the VB term, na? So I am not using this 1 by 10 because of this current source, but this 1 by 10 will appear. Okay, plus 1 by 10. Is it clear, guys? So this is the coefficient of VB. Now tell me, what is the entering current? Entering current. How to check the entering current at this junction? How to check the entering current? Look at this. There is no source in this branch, so no entering current on this side. This source will try to enter the current 20 upon 10. 20 upon 10 is 2. Okay. Now from this point, don't look at this branch. Just come to this point now, because it's a supernode. So this branch is over, this branch is over. We don't look at the supernode point. I mean the direct voltage source point. So what you do is you just directly jump from here to here and check the entering current again. Entering current in this branch is 2, so I have to add 2. I have to add 2, and then there is one more branch. Now in this branch, tell me, guys, you have 20 volt here and 0 volt here. So this 20 volt will try to give away the current. 20 by 10, that is minus 2. Okay, I hope it is clear. Tell me, everyone, I hope it is clear. Tell me, guys. Okay, sir, VB में 1 by 20 कैसे आया? Okay, let's write the coefficient of VB again. While writing the coefficient of VB, you are writing the nodal equation at this junction and asking the coefficient of this voltage itself. It means it's a self element. You are writing the nodal equation at this junction and asking the coefficient of this variable only. It means whatever branches are connected to this junction, this VB term, all those branches resistance have to be used. Okay, so now you can see that this branch is connected here, so it's 1 by 10. This branch is connected here, 1 by 20. Now you don't write this branch, no? You just go from this point to this point. Now this 1 by 10 will not appear, but this 1 by 10 will also appear in the coefficient of VB. That's why there is one more 1 by 10. I hope it is clear. Why this 1 by 20 came? Because this branch is connected to VB, na? That's why this 1 by 20 is came. Okay, I hope it is clear. And the entering current at this junction is, because of this 22 ampere, this current will also enter, and because of this 20, current will try to leave in this branch, 20 upon 10, that is minus 2. Okay, so this way you can write the equation. Now this 2 is cancelled. I hope it is clear, guys. Now you can write these equations in matrix form. If you are writing these equations in matrix form, then it will be, the first element will be 1 element, 1 by 20 plus 1 by 20 plus 1 by 20. Okay, and then minus 1 by 20, and then minus 1 by 20, and then 1 by 10 plus 1 by 20 plus 1 by 10. Okay, and here it will be VA and VB equal to entering current, and the entering current will be, tell me the entering current will be 3 here and 2 here. I hope it is clear. Now you can write this equation in matrix form like this. We call it Y bus. We call it Y bus. Electrical student, please focus on this. We call it admittance matrix, Y bus. Okay, those who are from electrical background, I told you that how to calculate Y bus. Y bus can be calculated using nodal equation. Okay, you can also call them buses. These are the buses. There are 2 buses. Okay, 2 unknown buses. Okay, So you can write the nodal equation and you can calculate the Y bus also. I hope it is clear, guys. I hope it is clear, and how to write the two variable equation and how to write the direct equation in two variables. Now there is one more way to write these equation. We know that this element is 1 1, y11, y12, y21, y22. Now how to write y11? You can directly write y11. 11 means this is junction number 1, this is junction number 2. Now if you want to write 1 element, it means it's a self element. This is also a self element. This is mutual element. 1 2 means mutual. Similarly 2 1 is mutual. So if you want to write 1 2 or 2 1, then 1 2 means this branch is used, 1 2 mutual branch is used, and the negative sign I have to use for mutual. So it's minus 1 by 20 here, and here also 2 1. 2 1 means 2 and 1. Between 2 and 1 there is a one branch, and if the one branch is there, then you can write minus 1 by 20 here also. Okay. Now what is 1 1? 1 1 means at this point the branches which are connected, we have to take the resistances of those branches. So at this point we know that this 20 is connected, so I have to write 1 by 20. Now this 1 by 6 will not appear because of this current source. So now we know that this junction is not only the single junction, it is connected with this junction also. So it's 1 by 20 plus 1 by 20 plus 1 by 20. Okay, this is self element. Similarly in 2 2 we have to write 1 by 20, 1 by 10, and then this 1 by 10. 1 by 10 plus 1 by 20 plus 1 by 10. I hope it is clear. So you can directly write these coefficients also. You can directly write the matrix form. You can directly write the matrix form easily. Okay. Y11 coefficient of VA. Yes, Y11 is the coefficient of VA, Y12 is the coefficient of VB, and this is the entering current of this first equation. Okay, I hope it is clear. Now let's try to make this matrix. Let's try to make this matrix in a different question. Let's say I have this question. Let's say I have this question, guys. And let's say we want to make a matrix. Let's say we have this question and this is grounded. Okay. 20 volt, 10 ohm, 20 ohm, 5 ampere, 20 ohm, 20 ohm, 40 volt, 60 ohm. Let's say we have this, and this is given as ground. Now let's call it VA and this as VB. Okay, and this is my ground point. Now I want to write the equation for VA and VB. So you can always use the matrix method. You can directly write the matrix method. Okay, VA VB and is equal to. Okay, so let's write the equation in matrix form. Directly you can write. Now how to write directly? It's very simple. Let's call it element node number 1 and let's call it junction number 2. So here I have to write 1 1 element. What does it mean? 1 1 means self element. At this junction, whichever branches are connected, I have to take their resistances in reverse way and I have to add them. So tell me 1 1 element. 1 1 element has to be 1 by 20 plus this 1 by 20 I cannot use because of this current source. So 1 by 20 plus 1 by 10 because this branch is also connected at this one junction. No? So 1 by 20 plus 1 by 10. This is only 1 1 element. I hope it is clear because only 3 branches are connected to 1 1. No? 3 branches are connected to one junction. So it's a, we are going to use the self element. No? 1 1. 1 1 means only those branches which I have to see which are connected to junction 1 only. So it's 1 by 20 plus 1 by 10 and this resistance I will not use. Okay. Now let's come to 1 2 element. Now tell me what is 1 2. 1 2 is the mutual, the mutual branch is used now. And in this mutual branch we have 10 ohm. So it means I have to write 1 by 10 and with minus sign. Okay. Is it clear, guys? Now it is 1 by this is my, you can say 1 2 element. Now 2 1 element. 2 1. 2 1 is again between 2 and 1. This is the branch which is used between 2 and 1. So it's a mutual branch again. So I have to write minus 1 by 10. Now what about 2 2? While writing 2 2 at this junction, this branch is connected, this branch is connected, this branch is connected. So I have to take the resistances in reverse way. So 1 by 60 plus 1 by 20 plus 1 by 10. Okay, I hope it is clear, guys. I hope it is clear. So this is my Y22. Okay, now how to write these elements? Entering current. Now tell me, what is the entering current at junction 1? Entering current at junction 1, there is no entering current in this branch. In this branch the entering current is 5. Okay, and in this branch this source will try to enter the current 20 upon 10. So 2 ampere will try to enter from this. I hope it is clear. Now what about the entering current at this junction? Here the element. How to write? Tell me, the entering current due to this source is 40 by 20, that is 2. Okay, 40 by 20 is 2, which will try to enter. And this current, this source will try to leave the current, because from minus to plus it is in this direction. So 20 upon 10, that is 2, and 2 will try to leave. So I have to write minus 2 here. Is it clear, guys? So this way we can write the matrix equation directly. Now you can simplify this. Now you can multiply the matrix and you can write the equation. Okay, I hope it is clear. Whenever there are two variables, whenever there are two variables, you can always use the matrix method to write the equation. Okay, I hope it is clear, because it's a simple method. Or you can use the direct nodal equation. How to write the coefficient of VA and the coefficient of VB? If you are writing the nodal equation at this junction and asking the coefficient of VB, then mutual branch has to be used. Mutual branch resistance has to be used. Okay, so you have to be careful in this case. Okay, I hope it is clear, guys. Tell me, everyone, tell me, is it clear or not? I hope this is clear. Okay, so remember, whenever we have multiple variable, then we can write this equation. But let me tell you, guys, in GATE exam or in BARC or ISRO or whatever, okay, because of the time limit, we don't have two variable. Even if the question has two variable, we can reduce them using source conversion. We can always apply the source conversion to reduce the number of variables, because let's say only this current is asked. Let's say find I naught. Only this current is asked. Find I naught. Now, if you want to find this I naught, then you can always reduce this junction or this side junction. You can always reduce this side junction or this side junction. Let's try to reduce the junction. Okay. Okay, I hope it is clear, guys. Let's say this I naught is asked. If I naught is asked, what you can do is you can always reduce either this side junction or this side junction. You can easily reduce that. How to reduce? Apply source conversion. It's simple. And try to reduce this junction. Or maybe you can reduce this side also. It's easy to reduce this side. It's easy to reduce this side. Why? Because of this current source. Because if there is a current source and in series we have this 20 ohm. 20 ohm will not be considered now. So you can remove this 20. There is no need for this 20. Okay. There is no need for this 20 and you can directly sort it. Now what you can do is you can always convert this current source into voltage source. If you can convert this current source into voltage source, this circuit will look like this. This is 10 ohm and this is 20 volt. On this side we have 20 ohm in series with the voltage source, and the voltage source is of 40 volt. 40 volt, and we have one more resistance, 60 ohm here. Okay, this is 60 ohm. On this side we have 20 ohm in series with 100 volt. In series with 100 volt. I hope it is clear, guys. Now you can see that only one variable is there, the lower point, and we can easily calculate this current I naught. Remember, only you have to be careful, and that point is, the careful point is, I mean, where you have to be careful, you cannot change the connection of this branch, because this branch current is asked now. So don't change this branch connection. Don't try to convert this branch. Okay. So you have to be careful about this. You can convert this side, you can convert this side. There is no problem at all. Okay. And you can reduce one variable, and that way you can calculate this current I naught. But sometimes what happens is they ask this matrix. There are 4 options, and in those 4 options they ask this matrix, or what they ask is they ask the trace of this matrix. They will write the matrix like this: VA, VB, and this is my C matrix. So what they ask is, they will ask trace of A. Trace of A. What does it mean? It means first you have to find this matrix A using nodal equation. You have to find this matrix A, and then you have to add the elements on the principal diagonal. It means you have to write the equation for two variables. You have to equation for two variables. You cannot reduce the variables, okay? You cannot reduce the junction. I hope it is clear, guys. So you have to understand how to write this matrix directly, okay? And it's an easy process. Using the coefficient 1, 1, 1, 2, 1, 2, 1, 2, 2, you can understand the meaning of these elements. 1, 1 means self element at junction 1. 2, 2 means self element at junction 2. 1, 2 means mutual element. The mutual branch is used, okay? And 2, 1 is again the mutual branch, okay? I hope it is clear, guys. I hope it is clear. Tell me, everyone, have you understood this? Say yes or no. Say yes or no. So you have to be careful while writing the direct nodal equation for multiple variable, okay? But in GATE exam, let me tell you guys, multiple variable equation will not be there. Okay, in GATE exam, only single variable is there. Even if in the exam multiple variable came, you can always reduce the variables, okay? You can always reduce the variable. Now, let's come to the next thing. And the next thing is, let me discuss about source conversion. Now, many students are confused with the source conversion. They think that dependent source cannot be converted. It's not like that, guys. Dependent source can also be converted, okay? They can also be transformed. Let's say I have a circuit like this. Let's say I take a circuit like this. Let's discuss about ten ohm. This is 10 ohm. Let's say we have this circuit, okay? 10 ohm, 10 ohm, this is 20 ohm. This is again 20 ohm. This current is I1 and this is 20 I1, okay? And we need to calculate this current I0. Find I0. Find I0. How to find this current? Okay? We need to calculate this I0. Find I0. Now, look at this question, guys. How to calculate this I0? How many junctions are there? Can you tell me? How many junctions are there? Can you tell me, guys? How many junctions are there? Everyone, let's participate in the question. Attendance is very poor today. Okay? Today, attendance is very poor. I told you that you have to make the attendance good. Okay? Then only I can continue this session. Okay? It's important, guys. Okay, so tell me, how many junctions are there? How many junctions are there? Tell me, everyone. How many junctions are there? Let's participate in the problem, na? Tell me, guys, how many junctions are there? Let's participate. Everyone, tell me, how many junctions are there? You are not replying. No name, no. No. Yes, there are 3 junctions. Shantil, that's correct. 3 junctions. One is this. This is a straight wire. So it's a single junction. One is this and one is this. Let's call it VA, call it VB, and let's call it ground. Now, this current is asked. How to calculate this current? We know that this is a closed circuit. This side, you can treat this side as a closed circuit. The entering current must be equal to leaving current. It means if I0 current is entering in this closed circuit, let's say, we can treat this circuit as a closed circuit. Na? If I0 is entering from here, I0 will leave from here. It means you need to calculate this branch current. So don't be confused with this current, okay? Don't be confused with this current, because many students are confused with this current. How to calculate this current? Guys, you don't need to calculate this current. Actually, you can calculate this current. No? KCL you can apply. This is a closed circuit. You can treat this network as a closed circuit, okay? This is a closed circuit. If it is a closed circuit, the entering current I0 must be equal to the leaving current I0, okay? Okay? So you can calculate this current. Now the question is how to calculate that. Okay, there are 2 variables, no? There are 2 variables, V and VB. So what I can do is I can always reduce the number of variable keeping this branch connection intact. You cannot change this branch connection because in this branch I need to calculate I naught. Okay, so you can apply source conversion. Now look at this. Can I convert this side? Can I merge this side in a single branch? Say yes or no. Say yes or no. Tell me guys, can I merge this branch and this branch in a single branch? Tell me guys, can I merge this and this in a single branch? Tell me everyone. Can I do like this? Say yes or no. Aminuddin, Ankit Goyal is GOAT. Yes, he's a GOAT. Okay, he's greatest of all time. Now what do you want to listen? Eh? I have no problem with anyone. Don't try to think that I have such kind of problem. I don't have any problem. I'm fine and I'm happy because everyone is doing their efforts. Everyone is doing. You can say everyone is devoting their time to the students, and everyone is trying to do his or her best. Okay, so no problem with that. You can watch his lectures also. They are also good. Okay, and you can learn from him. Okay, and if you are his student, then surely you are in the wrong class. Okay, so नहीं अरे नहीं best कुछ नहीं होता यार. Everyone is doing their work ना. Everyone is doing. Okay, now how can you compare? Either you are afraid of someone. Okay, either you are afraid of someone that you want to show something like, okay, because I mean this type of things came only when you want to show something. Okay, so that's not required actually. Anyway, let's come to the question, guys. Let's not deviate from the question. So I told you, look, in this question there are two variables. Now tell me guys, can I say that I can reduce this side? Answer is no, we cannot reduce this side. Why not? Why can't we reduce? I mean, why can't we remove this junction now? Because if there are two junctions, and can we remove one junction, one unknown? Answer is yes, we can reduce one junction, but not this junction. Why not? Why not? What's the problem with that? The problem with that is I1. Let's say you combine this. Let's say you convert this voltage source into current source. Let's say this voltage source is of 20 volt, and you want to convert this voltage source into current source. Okay, and then you want to combine it. Let's say you want to do this. Okay, let's try this. Let's try. The circuit is, let me redraw the circuit, 10 ohm, and then this side is 10 ohm again, and this will be my 20 I1. 20 I1. On this side we have 10 ohm. Okay, on this side we have 10 ohm, and now look at this side. Now look at this side. This 20 volt I can convert it to current source. Okay, and the current source value is, tell me, what is the current source value? 20 upon 20, that is 1 ampere. Okay, 1 ampere is the current source, and this 20 will come in parallel. This 20 will come in parallel. Okay, this 20 ohm will come in parallel. Okay, and there is one more 20 which will come in parallel. There is one more 20 which will come in parallel. I hope it is clear. Okay, and this current is I1. This current is I1. Tell me guys, this current is I1. You can see that. Now the problem is, why can't you combine them? If you can combine them, it will become 10 ohm. Yes, for sure it will become 10 ohm. But the problem is, this I1 current, this will be mixed. I mean, and this I1 decide this source. So you cannot change the connection of this branch. Okay? If the connection of this branch is changed, then the problem is, we don't know this branch current, where this branch current will go. Okay, let's you combine this. If you are combining it, it will become 10 ohm. For sure it will become 10 ohm. Okay, let's make it 10 ohm. Okay, let's make it 10 ohm. Okay, let's make it 10 ohm. And then again, you can convert back into voltage source. Okay, so let's convert back into voltage source. So it will be 10 ohm in series with 10 volt. 10 ohm in series with 10 volt. Okay. Now you can see that you have reduced this side. You have reduced this side into a single branch. But the problem is, where is I1 now? How to show this current I1? Because I1 will decide this dependent source. I1 is going to decide this dependent source. This is the problem now. So you have to be careful, guys. While applying the source conversion, don't try to convert that branch which is deciding the other sources. Okay, don't try to convert the connection of the branch, or don't try to merge this branch. Don't try to merge this branch, because this branch current is deciding this source value. That's why don't try to apply the source conversion on this side. I hope it is clear. Tell me, guys, is it clear or not? Tell me, everyone, is it clear or not? Tell me, everyone, tell me, is it clear or not? You cannot converge this side, because if you want to converge this side, then this I1 will be, this connection will be changed. The connection of this resistance will be changed. If the connection of this resistance is changed, then I1, you can't decide I1 then. If you can't decide I1, then the problem is you can't decide this 20 I1. Okay, this is the problem. So better you don't change this side. Don't try to reduce this side. So what I can do is I can reduce this side. Now you can always reduce this side. Okay, so let's try to reduce this side. I hope it is clear why you don't try to reduce this side. Okay, now let's try to reduce this side. Now you can always reduce this side. There is no problem at all. Okay, there is no dependency on this side. No? On this side, you can see that there is no current or voltage which is deciding the other element. So there is no dependency on this side. But on this side, there is a dependency. No? Current is deciding this source value. That's why don't try to reduce this side. Okay. So what you can do is you can always reduce this side. So let's try to reduce this side. Let's try to minimize the number of junction. But remember, you have to make this connection intact. Okay. You cannot change the connection of this branch, because the current I0, we have to calculate only this current. No? So that's why you cannot change the connection. Okay. So this 10 ohm I have to show like this. This 10 ohm will remain same. This current is I0. Now this is my 20 volt. Now this is my 20 volt, and here we have one more resistance as 20. We have one more resistance as 20, and here you have 20 ohm. Here you have 20 ohm. Okay. And this current is I1. Now let's come to this side. Now, on this side we have 10 ohm. We have this 10 ohm. Okay, we have this 10 ohm, and there is one more 10 ohm. So you can convert this into current source. No? So you will get 10 ohm in parallel. You will get 10 ohm, and you will get one more dependent current source. Now this voltage source will be converted into dependent source. 20 I1 upon 10, that is 2 I1. Okay, the value is 2 I1. I hope it is clear, guys. Tell me, I hope it is clear. So this voltage source can be converted into current source like this. Now this 10 and this 10 will combine, and it will become 5 ohm. Okay, so you can combine these two 10 ohms, and it will become 5 ohm. I hope it is clear. So it will become 5 ohm. You can see that this is my 5 ohm. Now what you can do is, now you can convert this 5 ohm in series with this current source. Again, you can convert this current source into voltage source. Okay, so let's convert this current source into voltage source. This 5 ohm will come in this series, and this will become 10 I1. I hope it is clear. So what you can do is, this 5 will go in the series, and this 5 will go in the series, and it will become 10 I1 like this. I hope it is clear. Tell me, everyone. Okay, so this way you can convert this side, and now you can see that only one junction is unknown now, VA. Only one junction, and this is ground 0. So what you can do is, now you can write the direct equation for VA and solve for I0. Okay, is it clear, everyone? Tell me, is it clear? Everyone tell me guys, is it clear? Now you can write the nodal equation. No? Direct nodal equation you can write. So tell me the coefficient of VA. It will be 1 by 20 plus 1 by 20 plus this resistance, that is 1 by 15, equal to entering current. Now tell me the entering current, guys. How much entering current? Entering current will be 20 upon 20, that is 1 on this side, 1, plus this 10 I1 will try to enter the current, that is 10 I1 upon 15. Okay, 10 I1 upon 15. So this is the entering current due to this source. I hope it is clear. Now what you can do is, now you can replace this I1 in terms of VA. I1 is this branch current, so I1 has to be equal to VA minus 0 by 20. Okay, VA minus 0 by 20. So you can replace this I1 with VA by 20. Okay, so this will become VA, and the coefficient of VA is 1 by 20 plus 1 by 20 plus 1 by 15 is equal to 1 plus 10 I1 upon 15, and I1 is VA by 20, so 10 by 15 into VA by 20. I hope it is clear. So now what you can do is you can simplify this, take this VA on this side and calculate the value of VA. Once you get this VA, you can easily calculate this current I naught. Okay. So I think now you can proceed this question. Now you can solve this question. I hope it is clear, guys. So you have to understand that source conversion is also applicable on the dependent sources. It is also applicable on the dependent sources. But while applying the source conversion on the dependent sources, you have to be careful. You have to be careful, guys. While applying the source conversion, you have to be careful, because in source conversion, you don't need to convert that branch which is deciding the other sources. Let's say this branch. On this side, you cannot merge them because this I1 is deciding this source. That's the main problem. That's why you cannot merge this side. You can merge this side. There is no problem at all. Okay. I hope it is clear, everyone. I hope it is clear. So now we have this question. Okay. Now we have this question, and in this question, this I naught is asked. So what you can do is this I naught, you can say that the same current I naught will appear here. Okay. And let's say this is grounded. Okay. And let's call it VA and let's call it VB. So now tell me, there are two variables. So obviously you can merge. Which side you want to merge? A side or B side? Tell me, guys. You want to reduce the number of junctions. You need to reduce. You cannot change this connection. This has to be intact. Okay. Because this current I have to calculate. Na? So this branch has to remain intact. Na? Now tell me which side you want to merge. This side you want to merge or this side you want to merge? Tell me, guys. You want to reduce the number of junctions. Na? To calculate this current I, you don't require two variable. Two variable is very lengthy process. So let's reduce the number of junctions. So obviously, whether B side you want to merge or A side you want to merge. Tell me, guys. B side you want to merge or A side you want to merge? Tell me, everyone. Which side you want to merge? B side or A side? I mean, this side you want to combine or this side you want to combine? Which junction you want to reduce? A or B? A or B? Tell me, guys, which junction you want to reduce? A or B? Answer is A. Yes. B don't want, you don't need to convert this, because the problem is, look at this branch. This branch is deciding this source. So you cannot convert this branch into this. Okay. The problem is with this I1. Okay. So that's why don't try to merge the B side. Try to merge the A side. Okay. Try to merge the A side, because on the A side, there is no dependency. No? There is no branch current or branch element voltage which is deciding the other source. No, sir. It's not like that. So what you can do is you can always merge this side. You can always merge this side. Okay. टेक्स्ट बुक होता है, उसको आपके लेक्चर सुनकर टेक्स्ट बुक लिखना चाहिए. It's okay. But anyway, these type of methods, let me tell you guys, the direct nodal method you will not find anywhere. Apart from my lectures, you will not find anywhere. Those teachers who are teaching this direct nodal method, they must have seen my lectures. Okay. That's for sure. Okay. Otherwise, it's not written in any books, because it's my experience and I have simplified the equations. I have simplified the equations so that you can be fast. Okay. I have simplified these equations, how to write these equations directly. So it's a lot of effort. So you don't take it lightly. Okay. So I told you, you can merge this side. No? You can merge this side. No problem with that. But don't merge this side. Because if you want to merge this side, then the problem is with this I1. Okay. I hope it is clear. Now you can reduce this side. So if you want to reduce this side, the circuit will look like this. So you have 10 ohm on this side, and this is again 10 ohm, and this is 10 ohm, and this will be 10 I1, and this is I1. Now look at this side. I want to merge them. So I don't want to write again and again. So what you can do is, if you want to merge them, this 20 will become 10. I'm writing directly. Okay. 10, and this 40 will become 20 volt. Okay. So you have to be fast. Na? I mean, don't write everything. You have to solve something in your mind. That's how you'll become fast. Okay, so you can merge this side and you can merge it like this. Now the only one variable is there, and that is this VB, and we need to calculate this current I naught. So first you have to calculate VB. You can write the direct equation now. For one variable you can write the direct equation. First calculate VB and then try to calculate this side current. Since the current is in upward direction, start from 0. 0 plus 20 minus VB upon 10. Okay, so I naught will be equal to, you start from the lower point because the current is in upward direction. Na? So start from the lower point, 0 plus 20 minus VB divide by the total resistance of this branch. Total resistance of this branch is 20 ohm. Okay, so this way you can calculate I naught current. This way you can calculate the I naught current. It's easy peasy. Okay, the only thing is you need to calculate VB first. Now the question is how to calculate VB. You can write the direct equation. The coefficient of VB will be, tell me the coefficient of VB. It's 1 by 10 plus 1 by 10 plus 1 by 20, and that is equal to entering current. Entering current is 1 from this side, 20 upon 20. Okay, 20 upon 20, 1 from this side, and this source will try to enter. 10 I1 upon 10 is I1. Okay, I hope it is clear, because there is a source in this branch and the source in this branch. So because of these sources, current will try to enter. That is 1 plus I1. Now we need to replace this I1. I1 is this branch current, VB minus 0 by 10. So you can replace this I1 as VB by 10. Is it clear, guys? And take this VB by 10 on this side, it will be cancelled. So from here you can calculate VB. Okay, from here you can calculate VB. Once you get this VB, you can put it here and calculate the value of I naught. I think it's easy peasy. Tell me, guys. So you have to be careful which side you want to merge. Which side you want to merge. Okay, don't try to merge this side, because otherwise it will be very problematic. Okay, things will be very complex because this I1 will be gone, and you will not find where the I1 is. Okay, what is the value of I1? Okay, that is the main problem. So first convert this side, the circuit will look like this. Now it's your part. Now you can easily calculate for I naught because only one variable is there, and I have already taught you how to handle this one variable situation. Okay, so what I did is we can find the current I naught like this: 0 plus 20 minus VB upon the total resistance, that is 20. This way you can calculate I naught. So to calculate I naught, we require VB. And what is VB? VB is this voltage. To find VB, we have to write the direct equation. So you should understand how to write the equation. If you know how to write the equation, just do it and calculate VB. Put the value of VB here and calculate the value of I naught. It's easy peasy. Okay. So this was about the source conversion, guys. I hope everyone has cleared this concept. Okay. Okay. So at this point, I think I have cleared all the concepts of nodal. Okay, I have taken all the concepts of nodal. Nodal concept काफी है. Yes, actually for gate exam you can skip mesh, because the mesh currents or I mean everything you can calculate from nodal. You can do everything from nodal. Okay. Sir, explain direct equation. I think no name. You have not seen my previous lecture. I mean I can guess, because you are asking the direct equation. You are asking about the direct equation. I have already taught you how to write this direct equation in the previous lectures. You can watch my previous lecture. There I have told you how to write the direct equation. Okay, in case of supernode also, and when there is one variable. So in today's class I told you how to write the direct equation when there are two variables. Okay, so everything is easy. Okay guys, sir exam mein direct or basic, which is best? If you are comfortable in direct method na, you will be very fast, believe me. So everywhere you should write the direct nodal equation. You have to do some practice na. You have to do the practice. Everywhere you have to write the direct nodal equation so that you can be fast. But if you are practicing the basic method, because the maximum teachers are teaching you the basic method, and that basic method is time consuming. You can see that in that basic method you have 2-3 extra steps that you need to do. So that is very time consuming. So if you have good practice on direct method, direct nodal method, you can always go with that method, and your speed will be fine, and you can save your time. So that's why I am telling you the direct method. So but you have to do more practice on the direct method because it's not that easy. From last 2 to 3 years, I have started teaching this method because usually I try to skip this direct nodal method. I usually tell the student with the basic method, but that basic method is very lengthy. Okay, every time you need to write all the current equation, branch current equation, then you have to take the sum of that, then you have to separate the coefficient. It's a lengthy. So in direct method, you can directly write the coefficient, and directly write the equation. Okay. Okay, guys. So I think I have told you everything, okay, about nodal. In the next class, what I'm going to do is I'm going to teach you something different. I mean, let's go away from network theory a little bit and try to understand average value and RMS value. Okay. So in the next class, we will discuss about average and RMS. Now what you can do is your homework is try to solve maximum questions on nodal and try to apply the direct method. Okay. And try to get the answer. Because if you are not practicing this method now, believe me, there is no advantage of telling this. There is no point of telling this method. Okay. So you have to write these direct equations. I mean, you have to do practice. You will make mistake, obviously, because mistakes is a part, na? But once you have started writing correct equation, believe me, you will love this method. You will love this because the time is saved. You become fast. So everything is happy. Okay. Everyone is happy. So timings are tomorrow's class. Timing is same. Tomorrow we have the same time at 9 p.m. Okay. So at 9 p.m. we'll meet again and we will try to understand average and RMS value. And then we will try to understand the basics of inductor. Okay. So I think in nodal analysis, I have told you everything. So you can practice questions from your workbook if you have some kind of workbook, let's say, or you can solve previous year questions also. Okay. So do the practice, guys. Don't skip this method. Don't skip this direct nodal analysis method. Okay. Try to solve some question, do some mistakes. Now, if you make mistake and you are not able to find the mistake, let's say, then you can send the problem on the Telegram channel. Na? And if you don't know my Telegram channel, then there is a link given in the description. Telegram group, Asu Jangda's Telegram group. That group is not my own group. Okay. That is BYJU'S group. So you can join that group also. But there you can ask my group also. Na? I will tell you my own group of Telegram in which I am taking the doubt of the students. So you can also join that group also. And I will clear your doubt on that group. Okay. So you can post your doubts or your questions on that group and I will handle those doubts. Okay. So, sir, ek din question ka session le liye. Yes, I will take the question session on the nodal also. There is no problem. Okay, I'll take, but this session is not about questions. I mean, this series is about the fundamentals. That's why I'm taking all the concepts. And moreover, I have taken so many questions now. I have taken already so many questions I have taken and I'm solving the questions itself. Okay, so just try to focus on these questions. Okay. So guys, I think it's time to stop the class, to stop the session now. So don't forget to subscribe our channel and please like this session if you have not liked it and press the bell icon so that you get the notification whenever the session will be live. Tomorrow we will have one session on RMS and average value. Okay, so don't forget to attend that session also because that is again very important because from this point onward we will more focused on RMS value. Okay, because RMS is used in calculating power. That's why RMS is important. So we will try to understand how to calculate the RMS and average value. And let me tell you guys, there is one more mobile app. So you can go to the Google Play Store and install this BYJU'S Exam Prep mobile app. There also you will find some free lectures and you can attend those lectures and you will be benefited from that. Okay. So thank you guys. Thank you for showing interest in this session. I hope you enjoyed. So आज के लिए इतना ही. Next time फिर से मिलते हैं. तो पढ़ते रहिए, मुस्कुराते रहिए. Next time मिलेंगे दोस्तों. Thank you and take care. Bye.